Hi, welcome to Analyticsorg. This is lesson 3 of the second module of our Python for Data Science course. Uh, this module is based on data manipulation and data management, and this is the second lesson on Numpy. So this is Numpy Part 2, and let's go ahead and get into it. Now, as with all my lessons, I have a full write-up on my website, analyticsforall.org. I will have a link for this down in the description, and feel free to check the website out. There's a whole lot more information than just the course. We've got all kinds of things, different languages, machine learning, that kind of stuff going on here. But let's go ahead, let's hop into our Jupyter Notebook. Scroll up and zoom in for you, which we can do here. All right. Now, if you saw the last one, Numpy is a module that we import, and I'm importing it as NP and aliasing it so I don't have to keep writing Numpy. But Numpy's got some cool features, some cool mathematical features. Last time we went over, I showed you how to do arrays and matrix, but now we're just going to show you some general math we can do here. Numpy.py will return pi. You know, we all learned that in geometry. You can do a square root, NPy square root. I give x. We can also apply some trig functions, sine, cosine, returns that. And we can do some basic statistics. Let's see. We can get a mean. Now, if you're not used to statistics, I'll give you a hint here. A mean, we're going to have statistics courses in the third module, but until then, I'm just kind of showing some stuff. So a mean equals an average. So that means what we're doing is we're saying we're going to add all these numbers up and then divide them by the fact there's what, 9 numbers, 7 numbers. So you add all these up, divide by 7, and you'll get 9.14. But when you hear average, that's what most people are talking about is the mean. We can also do the median. Now what the median is it's the middle ground here. So we look here, it's 9. So if you look, we got 7 numbers. So this is really easy to find the median here, especially because they're all in order. But you would go in order and you would have 9 as the median. You got 3 after it, 3 before it. And like I say, it's in order, so it's easy to see. If it wasn't in order, it would still order it before it needed it. For some reason, it does not do mode for you. And mode, if you don't know, mode is the most common value found in a list. So as you can quickly look at this list and see 2 appears repeatedly. So, but we can pull from the statistics module, we can pull stats from mode. Just that gives us mode. And we can get into some other statistics here. We have range, which range is your max minus your minimum. So the range here should be 16 minus 2. So you go there, and it's 14. Variance. The way variance works is, it's a little complicated. Let's take a second to talk about this. Okay, to kind of understand variance here, I'm going to go ahead, I'm going to put in another cell here just so we can write something down so we can look. Oops, I just ordered add another cell. Let's go ahead, mark down. All right, so to find the variance, what you're going to do is you're going to look at a list and you're going to find the mean. So first thing we do is we find the mean of the list, which we did already up here. And we had the mean is 9.14. Okay? I don't know what I just did there, but mean equals 9.14. Okay. Now, for each other element in the list, I'm just going to copy the list down here for easy use here. Okay, so each other element in the list, what you're going to do is you're going to subtract the difference here. So that'll give you 7, and that'll give you 5, and so I'm not going to do it, but 9.14 minus 2 gives you 7.14. And then each one of these things, because when you have 9.14 minus 16, you're going to get let's run this, sorry. You're going to get a negative number. So what you do with each of these values is you square them. You square them, you add them all up, and then you divide it by the number of values. So you divide it by 7, or 7 minus 1 if it's a sample population. We'll say again, we'll get into this later, but this is what variance is. It's useful in statistics, but it's kind of hard to understand the unit. But anyway, we can easily do the variance now just by running this, and we're going to get deeper into the statistics. I want to show you Numpy does a lot of stuff. Standard deviation is what you might have heard of. Now, the standard deviation is nothing more than the square root of the variance, but the standard deviation is going to make an awful lot more sense because the standard deviation says, on average, this list, every value in this list is, around 5 spots away from the mean. Okay, so it kind of gives you a good idea of a distribution of a spread. So I mean, what's a good purpose to think of standard deviation? You think about, you know, average heights of men or women in the population. So if you say the average height of a male in America is like 5'10", then the standard deviation is probably around 5 inches from there. So you could say that most men, are going to fall, 60% of men are going to fall within one standard deviation of that mean. And again, we'll get deeper into statistics later, but this is the kind of stuff we can do here really quickly. This should make this is a little less explanation needed here. We can round. So we got a list here. Notice they're all floats. They've got variables. And we can round them. Now, notice when we round 7, 6.7 becomes 7. 4.9 becomes 5. So this allows us to do some rounding. Another thing we can do now is floor. This may you've never heard of. Floor is basically just chops off the final value. So notice that 4.9 becomes 4, and 6.7 stays 6. And we have ceiling, which ceiling pushes everything up. So if you have 8.2 becomes 9. And so these are just some features that you can use to deal with. And you do this a lot in analysis. Things like this come in handy. So go ahead. I'm going to go back one less. Now this is the next thing. And again, statistics and visualization are the next module, but I'm just showing you we can do it. So let's go ahead. Let's take a look at this is just so we remind us what our list we're working with is. And here we've got something called matplotlib. Now, if you are doing this outside of Jupyter Notebook, you do not need to put this first line. This first line is nothing more than to allow me to see a graph inside the Jupyter Notebook. If you have Jupyter Notebook and you do not put this line in, you will not see the graph. So it's % matplotlib inline. And from matplotlib, I'm importing pyplot as plot. Again, we're going to get into graphs and stuff later. I'm just doing a quick show that we can use NP to graph things like the sign. So we'll take the sign of everything in this list. So we're providing the list. We're going to plot the list as our x and the sign as our y variable. And there we go. So you notice the list down here, this is our x, and the sign of each value. So it's going to take the sine of 2, sine of 5, sine of 7. That's the values we're plotting there. We can do the log. And again, we got the x as our x-axis. The log will be our y-axis. We'll get into logs later too. Just kind of quickly just showing what we can do with Numpy. I can even do both. Notice I've got 2 plots basically. I've got an x and a y here, and then an x and a y here. So I'm doing the sine and the log, and pyplot knows well enough, hey, I've got 2 charts, so it actually charts them both for me. So there's my x-axis, there's my log, this is my sine. Later we'll get into, I'll show you can change the colors to anything you want with it. Then you got this one cool thing here called linspace. This is another really cool feature here. And this, I like this, what it does here. Let's just go ahead and kick it out. And I want you to see, I picked a range from 5 to 50, and I said 10. I want 10 values from 5 to 50. So it automatically picked out values by 5 to give me 10. If I change this to 12, you notice now at 12 it starts to chop them up into little pieces. If I changed it to 5, we're going to get, so it's cool. So you could just pick a range, and then it's not a step. It's not like doing the step where I want just step by 10, but I'm saying is give me 10 values within this range that start at 5 and to 50. And it actually makes it to 50 here versus like our standard for loops. So using this, I got one more thing we're going to do. We'll just do one more plot, because Lin space I use a lot for just building out fake data. We'll just plot this by a division of itself, and there you go. It's a straight line where you can see 10 to 50, 1 to 10, because the highs are the 50, because 10 divided by 5, 50 divided by 5 is going to give you 10. All right, so again, thank you for visiting. My website's analyticsorg. If you like this video, hit like and subscribe. I know I kind of threw a lot at you in this video, and I promise in future ones we'll get more into the statistics and what all those things mean. I just wanted to show you the functionality of this Numpy. You know, it's hard to decide what to show first. If I showed statistics first, then I have to come back. It's just easier. You've seen Numpy. We're going to go on next lesson. We're going to pandas, and we'll learn about ceilings and pandas. Again, thank you for joining me. This is Analytics for All. If you like this, hit like, subscribe, leave me a message, let me know what you'd like me to work on, and please visit my website.